board and turn on my drawing tablet. All right, so the vertices of a triangle are at those points. Point X is 1, 0. Where do I write that?
Right at 1.
Yeah, let me do it and you tell me. Oh man, you gotta be kidding me. Hold on a second. I have enough but technical problems today. My drawing tablet doesn't want to work. Oh, there we go. All right, so right there?
Yeah.
Because that's an x coordinate of 1 and it's a y coordinate of 0. Okay, and we're going to label that as x, point X. Okay, and the next point is y, and it's at 3, minus 3. So always do the x first. So where do I go on the x?
Wait, what'd you say? Sorry.
So the point is 3, minus 3.
Well, if it's 3, minus 3, you do 3, positive 3, down 3.
Okay, cool. So if I count 3 over, I'm right there. I don't know, you can't see my cursor, but you'll see when I put the dot there.
Yeah.
Right there. And that is point Y. Let me just check where their next point is so I don't write over it. That's Y. And the third point is at 1, minus 3. So where am I putting that?
You're putting it, let's see here. Wait.
Relative to the letters X and Y, where am I putting it?
You're putting it right at -1 and -3.
Not -1. It's positive.
1, -3.
So the dot goes right between the X and the Y. Right there. Okay?
Yeah.
And that's 1, -3. I'm going to erase the X because it's going to get in the way of our triangle. So I'll label that as X. I'll label that as Y. And this point is Z. Okay.
Yeah.
So dilate the triangle with respect to the origin using a scale factor of 2. Okay, so first of all, if we draw the triangle, there it is. If I'm dilating with respect to the origin, where's my new points? X prime, Y prime, and Z prime. Where's my X prime going to be?
Your X prime is going to be right on the origin line, like right on the X axis.
This one I'm going to do in blue. But where? Where's that first point? The point that is X, where's X prime going to be? In other words, after you dilate it by a factor of 2.
It's going to be at 2, 0.
Exactly. Okay. So that's X prime. About Y prime. Now let's do the easy one next. About Z prime. Where's Z prime going to be?
Give me a minute. Z prime is going to be, it's positive 2, -6, so it's going to be at,
right? Let's see. 1, 2, 3, right there, right?
Yeah.
And that's Z prime. And finally, Y prime. Where's Y prime going to be? Y was at 3 comma minus 3. So where's Y prime going to be?
Y prime is gonna be at 6, -6.
Okay. So 6 is right there. -6 is right here. No, it's right here. I think. Did I count wrong? 1, 2, 3, 4, 5, 6. Yeah, no, this is it. Okay, so if I draw the new triangle, same exact shape as the other triangle, it's just twice as big. And it's also twice as far away from the origin. So it's not just twice as big when you dilate it. Okay, so then translate the image 8 units left and 6 units up. Okay, let me choose another color. Choose green. What is X double prime? Where is X double prime? In other words, they want you to start from the blue.
Y prime prime is gonna be at negative.
Let's go X, Y, Z, just so I can keep it straight. Just a second here. One moment. I got to label that. That's Y prime. Okay. And now in green, where's X prime? We'll take the simplest one first.
Well, X prime is going to be at...
Translate all 3 points, 8 units left and 6 units up.
It's going to be at -6, 6 is going to be X.
Yeah.
Z is going to be at...
Hold on. 0, 1, 2, 3, 4, 5, 6. -6 up 6. That's X double prime.
And Z is going to be at 0, -6. And then Y is going to be at...
Hold on. What would be easier here is if I actually had these points labeled, which I don't. So Z prime is at 2. Prime is at 2, -6, correct?
Yeah.
So take that point and move it 8 units left and 6 units up.
Mm-hmm.
Where does it go?
It goes at 6, -6.
Start with the X coordinate. Where's the X coordinate go?
X is -6, 6.
Well, the X goes to -6, right? Because we're starting with 2 and we're subtracting 8. So the X goes to -6. Where does the Y coordinate go? And I don't mean Y prime. I mean the Y coordinate of Z prime. Because we still move it up 6 units.
The Y coordinate of Z is 0.
Correct. So that moves it to right there. In other words, we're at -6, 0, right? And that will label Z double prime. Now the last one to do is the Y, and let's go back and label that coordinate so we'll know what we're looking at. That coordinate was, what was that coordinate? Y, it was 6 -6.
Yeah. So
take that coordinate and move it 8 left and up 6. Where do you go?
-2, 0, 2, 0, -2, sorry.
Well, get in the right order. The X
-2, 0.
There you go. It makes a big difference. It's a different point on the plot. Okay, so you always got to give the X coordinate first. And there's our third triangle. Notice that it is congruent with the blue triangle. It's exactly the same shape, exactly the same area. And finally, what are the coordinates of the newest image? You can figure that out, I gather?
Yeah.
All right, so we're done with 1. In other
Yeah.
words, they want what x double prime is, z double prime, and y double prime. But you can read it. You want to put numbers on them? You need to?
I already have.
Okay, cool. So let's look at the second one. The vertices of a rectangle are at those 4 points. Let's just see before I plot it. Let's see what they want. They want to reflect the rectangle in the x-axis and then rotate the rectangle 270 degrees about the origin clockwise. Okay. So I'm going to do this the same way. I'm going to start with one color, do the first transformation or translation, whatever they call these transformations, I guess. So I'll do it pretty quick here just to save time. So A is at -2. Do the x first. Up 1.
Done.
Okay. B is at, see, my problem is that I never know where the next point's going to be, so I'm writing on top of it as I'm doing it. So let me just put the points on here. -5, 1. Boy, 1, 2, 3, 4, 5. This is really hard on the eyes. -5, 3, and -2, 3. So there's our rectangle. What happens when I reflect that in the x-axis? Where does it go?
It goes 108. It goes to the diagonal box.
I like to think of that as a vertical reflection. In other words, if I take that pink box and I reflect it over the x-axis, it's got to go to here.
Yeah.
Is that 2 units high or 3 units high? That's 2 units high. So there's the reflection. And in terms of the coordinates, you'll notice your x coordinates don't change. The only thing that changes is your y coordinates. Right?
Yeah.
All 4 points, the x coordinate is the same between the blue and the pink. Okay, now they want us to rotate that 270 degrees clockwise about the origin. Okay, the way I do this, they may teach you a different method. I draw a straight line to the origin like that from the nearest corner. And then I rotate that straight line. Well, 270 degrees clockwise, this is clockwise, means that that line, when I'm done, is 90 degrees, right?
Yeah.
I think that's the easiest way to think about these. Now, that point right here that line is connected to, same point, right there, has to be. Okay? Now, let's look at the other points. This is A, B, C, D. So let me make sure I've got this right. That's A. Let me make sure I'm in the proper color pen. So this is A. B is over here. C, and this is the only part that can be confusing, is which points are which after you've done it. So on the blue, where's my A and B?
The
The top or the bottom of the blue rectangle?
The bottom.
Actually not. Think of what you're doing when you're reflecting that rectangle over the x-axis. Think of it as you have a playing card and you rotate it over the line AB. So this is actually B prime. This is A prime. And this down here is C prime, and this is D prime. Because I did not translate this. I did not just slide it down. If I had slid it down, you'd be right. The A and the B would be at the bottom. But I flipped it over. Okay?
Yeah.
With me? Okay.
Yeah.
So now, when I rotate this whole thing around 270 degrees, it should look something, if I'm not mistaken, like this. And I know that that is A double prime because the A's have to match up. In other words, whatever corner of that rectangle I've connected to the origin to rotate, well, this, let me use a new color yet here. This line right there needs to connect with A double prime, right?
Yeah.
Now, the question is, what is this point right here? And I may not have actually drawn this correctly. This new figure might look like this. Okay? In fact, I think it does. Where's B double prime?
In a minute.
In this figure. Actually, I think I was right in the first place. I think it is the blue or the orange. Let me make that in orange. I think it's going to end up looking like this. Okay. Now, to figure out what corners are what, it's a little confusing. So do the same thing with B prime right here. Connect it to the origin with a straight line. Revolve that straight line 270 degrees clockwise. Where does it come out? Comes out right there. So this has to be B double prime.
Yeah.
Okay. Now, I could do the same thing to C, but I guarantee you this is C double prime right there. And this is D double prime. And that kind of matches the figure. The A and the B are on the long side of that rectangle after the reflection, and they should still be on the long side of that rectangle after the rotation. And they are. They're still 3 units apart. And the A and the D are 2 units apart.
Yeah.
So, this is a little tricky, but I tell you what, one way to look at this, Jackson, a little differently, is instead of doing a 270 degree clockwise rotation,
Just do it 90.
do a 90 counterclockwise. Okay? And if I do a 90 counterclockwise, then B clearly, if I rotate that 90 degrees, it's that line right there, pointing at this vertex. So that's got to be B double prime. And you could do the same thing with C. C is going to end up being there. And the same thing with D. Go ahead.
Oh, I'm just done with it.
Oh, okay. I thought you had a question. All right, should we go to the next page?
Yeah.
All right. And that would be this one. I want to say something about parallel lines. There's few subjects that are more important in math than two parallel lines with a transversal. They make it a lot harder than it needs to be. Okay? Here. There's my two parallel lines. There's my transversal. How many angles I've got? 1, 2, 3, 4, 5, 6, 7, 8. How many unique angles do I have? Are all 8 of those angles different?
No.
No, there's only 2 unique angles. It's 1 and 2. Every other angle is either the same size as 1 or 2. Okay? And so you get 2 angles only. And most of the time, one of them is acute and one of them is what?
Oh, one of them is obtuse.
Yeah. Notice the way I've drawn it. It's easy to tell which is the acute angle and which is the obtuse angle. So is one acute or obtuse?
Well, one is 115. And so it's 4.
We're not doing your problem yet. Is one acute or obtuse?
Well, one's obtuse and 2 is acute.
Okay. So if I want to know which one matches 1, we'll start at the bottom. Is it 7 or 8?
Oh, what'd you say?
If I want to know, starting at the bottom, which one of those angles is the same as number 1?
7.
Which one is obtuse? That's the question you need to ask. So every obtuse angle, there's an obtuse angle, there's an obtuse angle, there's an obtuse angle, and there's an obtuse angle. Whatever that angle is, all 4 of those are the same thing. Every acute angle is the same. And that is all you really need to remember about parallel lines and a transversal, is you only have 2 angles. And is all you have to do is tell whether one is acute and one is obtuse. Now, there is a small problem with that reasoning. Occasionally, they're going to give you something that looks like that. Now, I've got 8 angles, but I can't tell which is obtuse and which is acute. And they may not all be exactly 90 degrees. One might be 91 degrees, and its pair might be 89 degrees. Okay? Mm-hmm. So to handle this situation, in other words, my method doesn't work really well when that line is close to vertical.
Yeah.
And this is the reason that they teach you this more complicated method. Even though they teach it to you like this, they have all kinds of special names for these pairs of angles. I'm going to ask you, and you give me the name. What is 1 and 4?
1 and 4 is
Okay, the proper answer would be they're vertical angles, and vertical angles are always the same.
They're always the same, yeah.
So 1 is equal to 4, and they're vertical angles. What is 1 and 2?
1 and 2 are
It's called a linear pair.
Linear pair, yeah.
And what are they? What is their relationship? They're not equal, obviously. One's obtuse, one's acute. What are they?
They're the opposite of each other?
No, they're supplementary. Supplementary means they add to 180. And that's important. Okay. What is 1 and 3? What's that? What are those called?
1 and 3 are corresponding.
Also, no, they're a linear pair also.
Well, yeah, because
Okay.
they are.
Corresponding is these. 1 is corresponding with 5. Notice that it's in the same kind of position. They're both obtuse, so they're the same. Also, 2 is corresponding with 6. 4 is corresponding with 8, and 3 is corresponding with 7. Now, they also have other names. 3 and 6 are what? There's a specific name they want you to memorize for 3 and 6. Alternate, because they're on opposite sides of the transversal. Interior, because they're inside the two parallel lines, right?
Yeah.
So it's alternate, interior, angle. Okay. And what is 1 and 8?
1 and 8 are alternate exterior angles.
Yeah. It's alternate because they're on opposite sides of the transversal. And it's exterior because they're outside of the two parallel lines.
Yeah.
And the theorems say that alternate interior angles are equal, as we can see they are, because they're both acute. And the theorem also says alternate exterior angles are equal, and we can see they are. So even if I gave you a picture like this, you would know that this angle 1 is equal to that angle 2 because they are alternate interior.
Yeah.
Now, I hate to stop here, but unfortunately I have a 7 o'clock tonight that I got to get to. So we'll just have to pick up next time. This is good stuff, this parallel lines. Pay attention to this. You're going to run into parallel lines and transversals for the next 3 years.
Okay.
Okay? All right. Have a good evening, Jackson. Talk to you later. Bye-bye.